Welcome all in today's video lecture. Today we are going to show you the fractional factorial design using Minitab. To begin with these things, let me introduce myself. I am Shobhan Sarkar, the PhD student in the Department of Industrial and Systems Engineering, IIT Kharagpur, and also the teaching assistant of the subject of design and analysis of experiments. To begin with these things, let me have a content in today's lecture. There is a fractional factorial design, the steps through the example and the references are given. To begin with these things, we have to first start with an example. This example is a chemical product is produced in a pressure vessel. A factorial experiment is carried out in the pilot plant to study the factors thought to influence the filtration rate of this product. The four factors are temperature, pressure, concentration of formaldehyde, stirring rate. So, these four factors are abbreviated as A, B, C and D. Each factor is present at two levels. The design matrix and the response data obtained from a single replicate of 2 to the power 4 experiment are shown in table 1 and figure 1. The 16 runs are made in random order. The process engineer is interested in maximizing the filtration rate. So, here in table 1 we can see there are 4 factors A, B, C and D is a run level 1 A, B, A, B, C, A, C, B, C, A, B, C, D, A, D, B, D, A, B, D, C, D, A, C, D, B, C, D and A, B, C, D and their corresponding filtration rate, and this is the design. So, in this design we have to show how to conduct the fractional factorial design. So, in that case 1/2 fraction of 2 to the power 4 design will have to be conducted. So, 2 to the power 4 design, if we conduct these things, so we have to select the design 2 to the power 4 minus 1 design with resolution 4 and I equal to ABCD. So, this is the data and this is the corresponding design. From this data we have selected 8 runs and with basic designs A, B and C. D is the generated from ABCD, ABC. So, corresponding plus minus signs are given. A, for A the plus minus sign are minus, plus, minus, plus, minus, plus, minus, plus. For B minus, minus, plus, plus, minus, minus, plus, plus. For C minus, 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 plus, 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 plus. For D it is just product of this, as you know, that is a minus, minus and minus, the product is minus, plus, minus, minus is plus. Similarly, minus, plus, plus, minus, plus, minus, minus, plus. So, treatment combination we have got from this table and their corresponding filtration rate. So, now we are going to show you how this can be analyzed through Minitab. So, from these things we have just write it down in an Excel file, this run and the filtration rate, that is 1 to up to 8 runs and the filtration rate up to corresponding run, the filtration rate is recorded. So, first we open the Excel file, we have copied it into this Excel file for our future references. So, first open Minitab window. Initially we have to copy this thing, ultimately it will be used later, but initially we have to copy it. So, after copying this thing you can see the run and filtration rate are shown in the Minitab environment. So, after that click the stat bar. Under the stat bar DOE option is there. So, and then under DOE factorial option is there and under factorial create factorial design option is available. So, after clicking it we have got a set of options under the type of design, then number of factors, then display available designs, then designs, and the factors, options, results will be coming one by one. In that case, in our particular case, we are selecting 2 level factorial specify generator. Display design available for our case is resolution 4, maximum resolution 4. Then coming to the number of factors, here our design is, as you can see, our design is 2 to the power 4 minus 1. Basically, the basic design becomes 2 to the power 3 design, as here the basic design you can see A, B and C are the basic design. So, here we can select 3 design, then click the designs. Here we will select the full factorial for the 2 to the power 3. Here the design is full factorial, runs is 8, resolution is full and 2 to the power 3 design. Design generators we have to specify. Here the design generator, if you look back into the slide, we can see that design generator is D equal to ABC. So, we will have to put it into the slide. Once we complete these things, we will click OK. Then these options are available. Initially it was not available, now they are available. Factors, options and results. So, clicking the factors, we can see these are all the factors we can see A, B, C and D. So, here is name, we can easily name them, but for the sake of the easy handling, we do not name this, we only keep the abbreviation as it is, that is A, B, C and D. It is a numeric type, not text. It is a high level and low level, abbreviated as +1 and -1 respectively. So, click it OK. Then go to the options. Here in these options we can see the fold design, fraction designs. So, in fold design we do not fold, we are not going to show you the fold on all factors. It is a very simple straightforward applications without folding. So, we keep it as it is. So, here in this fraction we will use the principal fraction, that is I is equal to ABCD. So, click OK. Go to the result section, we are not going to do anything with it. So, leave as it is. So, click OK. So, once we click OK, it ultimately leads you a generation of another worksheet. You can see minutely the worksheet 2. Initially it was worksheet 1, now it becomes worksheet 2 with 1, 2, 3, 4, 5, 6, 7, 8 columns. Initially we have to first select and make it order the standard order column. Here as you can see it is placed in random 1, 6, 7, 5, 4, 3, 2 and 8. So, we have to keep it in order. So, in order to keep it in order, we have to first select stat, then coming to the DOE, then click the display design, here this option. Once we click it, the options would come that order for all points in the worksheet. So, we will click it, the second option, the standard order for the design, and click it OK. Now, we can see the order has been maintained 1, 2, 3, 4 up to 8 and the corresponding run order is also given. The A, B, C, D, under the A, B, C, D plus minus are arranged in a proper manner. Now, this is the time to put the corresponding filtration value. So, from here we have to first copy and here we have to paste it. After pasting these things, final analyzable worksheet looks like that: standard order, run order, center points, blocks, A, B, C, D, filtration rate. Now, click the stat DOE factorial design and then analyze factorial design. Here we can see the filtration rate is available. So, select it as response variable. So, terms we are not going to do anything with it, covariates, options, so many options are available, 95% confidence level is given, two-sided test we are going to do, it is a by default setting. So, is there any requirement of transformation of the data? No requirement, no transformation, it is a by default setting. So, we are not going to alter them at all. So, we leave it as it is by clicking OK. Now, click the stepwise. Again also we are not going to do anything with it. So, method is nothing, here we are not going to do any stepwise forward selection and the backward selection. The by default selection, by default method we are doing here. So, clicking the graph, here so many graphs are available, you can see FX plot, Pareto, normal, half normal if you want to get, so you can also get the half normal. The residuals for plot for regular, standardized and deleted, and residual plots for individual plots, for histogram, normal plots, residuals versus fit, residual versus order. So, we are going to see these things in a same window. So, 4 in 1. After that click OK. Then results, leave it as it is, then storage, nothing to do with it, but if anyone wants to get the value of Cook's distance, leverages, residuals, fits, effects, coefficient, design matrix, one may easily opt for that, but here we are not going to show here anything. After clicking this, we are getting these values. So, as you can see in this output results, the Pareto chart we are getting, here the effects, that is AD, A, AC, D and C seem to be very important, and this is a effect chart, and based on these things we can easily neglect the B and AB. This is a normal plot for the effects with alpha is equal to 0.05, and here is the results we can see. So, coming to the starting point, we can see that it is a fractional factorial design, it is a 1/2 fraction basically. So, factors which were initially taken were 4, basic design is 3, then resolution is 4, run we have considered is 8 because it is a 1/2 fraction. So, initially it was consist of the 16 design. So, 1/2 fraction it means in the principal fraction consisting of only 8 runs where it is shows. In replicates is a 1 replicates, fraction is 1/2, blocks is 1, design generated D is equal to ABC. So, here in the fractional regression we can see the analysis of variance ANOVA table. We can see the A, B, C, D, then 2-way interaction A, B, A, C, A, D. We have to keep it in mind that B variable is not significant. That is why also the A, B can be neglected and B can also be neglected. So, A, C, D, A, C and A, D are the significant factors. So, ultimately we can get also the effect of each of the term A, B, C, D, A, B, A, C, A, D. For all terms we are getting the effects value. For example, for A the effect estimate is 19, for B it is a 1.5, C is 14, D is 16.5, similarly for all. As we have already experienced from the Pareto plot that B value is very less and A, B value is very less, we can also see from here. So, A, C, D holding the very high value, that is the 19, 14, 16, and corresponding AC and AD are also holding the very higher values. So, corresponding coefficients are also given, the p value is also given, and finally, we are getting the regression equation of filtration rate, which has been considered as the output variable. So, filtration rate is 70.75 plus 9.5 A. If we neglect this, then 0.75 B should be neglected, then 7 C 8.25 D minus 0.5 A B minus 9.25 A C plus 9.5 A D. Here if we consider, if we neglect the B and A B, then left of the portion will be the final filtration rate equation, regression equation for the filtration rate. So, it is this LSS structure: I plus ABCD, A plus BCD, B plus ACD, C plus ABD, D plus ABC, AB plus CD, AC plus BD, AD plus BC. So, coming to the PPT presentation, we can show you all the steps. You can follow all the steps very clearly and practice it in your own laptop. So, step 1, step 2, step 3, 4, 5, choosing the design, step 6, design generator, step 7, factors and their levels, step 8, fold over design, whether we are going to choose it or not, then printed results, what exactly we are going to get the results, then new form of data as we have discussed already, then display the design, it is required to make it order, and finally, the new data worksheet was generated, then filtration rate was inserted. Using these things, then we can go for the analyze the factorial variable, factorial design. Then filtration is selected as response. This Pareto chart is generated, and A, C, D, AC and AD are found to be very significant factors, and this ANOVA table. Thank you.